For almost 5 decades, a small spacecraft has been traveling farther from Earth than anything humanity has ever built. Its name is Voyager 1. Launched in 1977, the spacecraft began its journey during a time when computers were primitive by today's standards. There were no smartphones, no modern internet, and no powerful artificial intelligence systems helping engineers analyze data. Yet Voyager 1 survived. It passed Jupiter. It flew by Saturn. And eventually, it continued beyond the outer regions of the solar system. Today, Voyager 1 is traveling through interstellar space, sending incredibly faint measurements back toward Earth. Every signal is precious. Every piece of data takes an enormous journey before reaching the antennas of NASA's Deep Space Network. And despite its age, Voyager continues to teach scientists about a region of space that no human spacecraft had explored before. But what exactly is happening around this distant explorer? To understand the mystery, we first have to understand where Voyager is traveling. The Sun constantly releases a stream of charged particles called the solar wind. This wind travels outward from the Sun and creates an enormous protective bubble around the planets. Scientists call this region the heliosphere. Eventually, the solar wind becomes too weak to dominate its surroundings. At that boundary, the spacecraft enters an environment controlled increasingly by the interstellar medium. Voyager 1 crossed this boundary in 2012. That moment represented one of the greatest milestones in space exploration. For the first time, a human-made spacecraft was directly measuring conditions beyond the heliosphere. But crossing the boundary did not reveal a simple line separating two completely different regions. Instead, Voyager found something much more complicated. The particles change. The plasma environment change. Cosmic rays became more prominent. And the magnetic environment behaved in ways scientists had not completely anticipated. This discovery showed that the edge of our solar system is not a simple wall. It is a complicated interaction zone where the influence of the Sun meets the surrounding galaxy. And Voyager was measuring it from the inside. Now imagine what that means. Scientists on Earth cannot simply send another spacecraft to collect the same measurements instantly. Voyager is billions of miles away. Its instruments were designed decades ago. Its power supply is weakening. And communication becomes increasingly difficult as the spacecraft travels farther into the darkness. Yet the data continues to arrive. This makes Voyager's measurements incredibly valuable. One of the most interesting areas of research involves plasma. Plasma is a state of matter made up of charged particles. It exists throughout space and interacts with magnetic fields. In interstellar space, these interactions can create waves and fluctuations that carry information about the surrounding environment. Voyager can detect some of these changes. By studying them, scientists can estimate properties of the extremely thin material surrounding the spacecraft. And the results have challenged some expectations. The space between stars is not completely empty. Even in regions where matter is incredibly sparse, particles can interact across enormous distances. Magnetic fields can stretch through space. Energy can travel through plasma. And disturbances produced much closer to the Sun can continue moving outward long after their original source has disappeared from view. This creates a strange picture of interstellar space. It may look completely dark and empty from our perspective. But on the scales Voyager is measuring, it is an active environment. And this is where sensational stories sometimes begin. Whenever Voyager detects an unusual measurement, people naturally ask whether something mysterious could be responsible. Could there be another spacecraft? Could there be an unknown object? Could an intelligent civilization exist somewhere nearby? These are fascinating questions. But science requires evidence. An unusual measurement is not automatically evidence of extraterrestrial technology. Natural plasma processes can produce extremely complicated patterns. Cosmic radiation can create unexpected signals. Magnetic disturbances can change with time. And instruments operating for decades can also develop technical problems. So scientists must separate genuine discoveries from false alarms. That process can take time. Researchers compare observations. They examine historical data. They test different physical models. And they look for independent confirmation. Only when an unusual result survives these tests does it become a serious scientific discovery. Still, Voyager's journey has opened an extraordinary possibility. As technology improves, researchers can analyze old spacecraft data in ways that were impossible when the measurements were originally collected. Modern computing systems can search through enormous datasets for patterns that might have been overlooked decades ago. Artificial intelligence could become especially useful in this process. AI can examine huge collections of measurements and identify correlations that would be difficult for humans to find manually. But AI does not automatically know whether a pattern has an intelligent origin. It can identify something unusual. Scientists still have to determine why it is unusual. And that distinction becomes extremely important when discussing claims of mysterious signals. If a future analysis ever found a pattern that appeared artificial, researchers would need to investigate it from every possible direction. Could the spacecraft itself have produced it? Could the sun be responsible? Could the signal come from a known astronomical source? Could it be an interaction between particles and magnetic fields? Only after these explanations were carefully tested would scientists begin considering something more extraordinary. And that is where Voyager's story becomes truly fascinating. Because the spacecraft is traveling through an environment where humanity has almost no direct experience. Every measurement expands the map of what we know. Every unexpected result creates another question. And every question pushes us farther into the unknown. Voyager 1 was never designed to solve the mysteries of the entire galaxy. It was designed to explore the outer planets. But its mission evolved far beyond its original purpose. Now it is helping humanity understand the space between stars. And perhaps its most important contribution is still ahead. Because the farther Voyager travels, the more isolated its environment becomes from the immediate influence of the Sun. Its instruments may continue revealing subtle changes in particles, magnetic fields, and cosmic radiation. Those observations could help scientists understand how stars interact with the space around them. They could even improve our understanding of the environments that future interstellar spacecraft might one day have to cross. Voyager is therefore more than an old machine. It is an experiment that has been running for nearly half a century. And somewhere in the darkness, it continues moving forward. But what if one day its data reveals something that cannot easily be explained? What if an unusual pattern appears again and again? What if independent instruments confirm it? And what if, after every natural explanation is tested, the mystery remains? That is where the story takes an even more fascinating turn. Because then scientists would have to ask a question humanity has wondered about for generations. Are we truly alone? And if the answer is not what we expected, Voyager 1 could become one of the most important witnesses in human history. But for now, the spacecraft continues its lonely journey. Quietly measuring the invisible environment around it. Quietly sending its faint signals toward Earth. And quietly reminding us that beyond the planets lies a universe we are only beginning to understand.